Welcome to quicktechie.com, Palo Alto Networks, Network Security Generalist Certification Training. Let's dive into next module.
App ID Technology Overview. Okay, let's talk about App ID. Think of App ID like a special detective for your network traffic. Normally, security devices might only look at the port number, like port 80 for web traffic. But many different applications can use the same port, or even try to hide on different ports. App ID doesn't just look at the port. It looks inside the data packets to figure out exactly which application is running. For example, is that traffic on port 80 actually just web browsing, or is someone trying to use BitTorrent or a streaming service? App ID can tell the difference. How does it do this? It uses several tricks. It has a list of known application patterns, like fingerprints, called signatures. It can also decrypt encrypted traffic, like HTTPS, to see what's inside. It can understand the language applications speak, protocol decoding, and even guess what an application is doing based on its behavior, heuristics. Why is this important? Because once you know exactly which application it is, like Facebook, Dropbox, or a specific business application, you get visibility. You can see exactly what people are using on your network. And most importantly, you get control. You can then create very specific security rules. For instance, you could say, allow normal web browsing, but block the upload function within Facebook, or allow our approved video conferencing app, but block all other streaming services. This makes your security much more precise and effective. Identifies applications traversing the network, regardless of port or protocol. Okay, let's focus on the first point. App ID knows what application is running, no matter which port it uses or what basic network language, protocol, it seems to be speaking. Imagine network traffic is like cars on a road. Traditionally, security devices only looked at the lane the car was in. That's like the port number, like port 80 for web traffic, and maybe if it was a car or a truck, that's like the basic protocol, like TCP. But today, many different types of cars, applications, can use the same lane, port. For example, both normal websites and file sharing programs might try to use port 80 or 443. Also, some cars might try to sneak into a different lane they shouldn't be in to hide what they are. App ID is different. It doesn't just look at the lane or if it's a car or truck. It looks inside the car to see exactly what kind of vehicle it is. Is it a family sedan, like normal web browsing? Is it a delivery van, like a specific business application? Is it a sports car trying to pretend it's something else, like a risky application hiding? So, even if BitTorrent traffic tries to run on port 80, which is usually for web browsing, App ID can identify it specifically as BitTorrent. It doesn't care that it's using port 80, it sees the application itself. This is the core idea. Identifying the application layer, not just the network layer details like port and protocol. Uses multiple techniques. Okay, let's talk about how App ID figures out exactly which application is running. It's like a detective using several different clues to identify someone, not just one. First, it uses application signatures. Think of these like unique fingerprints for thousands of known applications. App ID looks at the data traveling across the network and compares it to its database of these fingerprints. If it finds a match, like seeing the specific pattern for, say, Facebook or Zoom, it knows what application it is right away. Second, it uses protocol decoding. This is like understanding the specific language an application speaks. Different applications follow different rules or steps when they communicate. App ID knows these rules for many common application languages, protocols. By understanding these conversations, it can confirm or identify the application. For example, it knows the specific way a web browser talks to a web server using HTTP, which is different from how a video streaming app might start its session. Third, decryption is very important, especially now that much internet traffic is encrypted, like HTTPS. If the traffic is locked with encryption, App ID needs to unlock it, decrypt it, to see the actual data and signatures inside. Without decryption, It might just see encrypted data and wouldn't know the specific application if it's hiding behind encryption. Once decrypted, it can apply signatures and protocol decoding. Finally, heuristics. This is like making a smart guess based on behavior. If App ID sees traffic that doesn't perfectly match a known signature or protocol, but it acts like a certain type of application, for instance, it transfers data in a pattern typical of file sharing, it can use heuristics to make an educated guess about what it is. This helps identify newer or less common applications, or ones trying to evade detection. By using all these techniques together, fingerprints, understanding the language, unlocking coded messages, and making educated guesses, App ID becomes very powerful and accurate at identifying applications, even if they try to hide or use unusual ports. Provides visibility and control over application usage and behavior. Okay, let's talk about what happens after App ID identifies the application. The main benefits are visibility and control. First, visibility. Because App ID knows the exact application, like YouTube, Salesforce, or even a specific internal application, you can see exactly what people are using on your network. You get reports showing how much bandwidth Facebook is using, which users are using BitTorrent, or if there's traffic from an application you don't recognize. This is like having a clear picture of all the different activities happening, instead of just seeing general web traffic. You see the usage of specific applications and understand their typical behavior. Second, control. This is where you use the information App ID gives you to make decisions. Since you know the exact application, you can create very precise security rules. For example, instead of just blocking a port, you can block the entire BitTorrent application, even if it tries to use a common web port. You can allow employees to use a business application but block risky features within it, like uploading sensitive files to a public cloud storage app. You can allow streaming video but limit the amount of bandwidth it can use. So, App ID gives you the eyes to see exactly which applications are running, visibility, and the power to decide exactly what you want to do with each one, control. This lets you manage application usage and behavior on your network very effectively. Enabling granular security policies. Okay, let's focus on enabling granular security policies. Think of granular as meaning very detailed or specific. Before App ID, security policies were often based only on simple things like port numbers or basic protocols. This was like saying, allow all cars in lane 80. But as we know, different types of cars use that lane. With App ID, because the firewall knows the exact application, like Facebook, YouTube, or your company's specific customer database application, you can create security rules that are very, very specific. This is what granular security policies means. Instead of just saying, allow traffic on port 80, you can now say, allow the application, web browsing, for everyone. Allow the application, Salesforce, only for the sales team. Allow the application, Facebook, but block the specific function within Facebook called file transfer. This is a great example of blocking an activity within an allowed application. This granular control is also super important for applying other security protections. Services like checking for viruses, threat prevention, blocking bad websites, URL filtering, or sending suspicious files for analysis, WildFire, can now be applied directly to specific applications. So you can say, check all web browsing traffic for malware, but maybe skip inspection for a trusted internal application to save resources. Finally, this ability to make detailed rules based on applications works the same way whether you're using a physical Palo Alto firewall, part of the Strata platform, or a cloud-based security service like Prisma Access, part of the SASE platform. It provides a consistent way to manage security policies based on applications, no matter where the users or data are located. It gives you precise control over exactly what applications can be used and how they can be used. Allows policy rules based on specific applications. Okay, let's explain. Allows policy rules based on specific applications. Imagine a traditional security rule that says, allow all traffic on port 80. This lets people browse websites, but it also lets any other application that uses port 80 through, even if it's something risky like a file sharing program or a game trying to hide. You have no control over the specific type of traffic, only the lane it's in. With App ID, the firewall knows exactly which application is running. It knows if it's Facebook, or Zoom, or your company's internal email system. This allows you to create rules that are based on the application's name, not just its port or protocol. You can make rules like, allow the Microsoft Teams application for everyone in the company. Block the BitTorrent application for all users. Allow the Salesforce application only for users in the Sales group. This is much more effective because you are controlling the actual application activity on your network. You're not guessing based on the port. You're making decisions based on the confirmed identity of the application. This is the power of creating policies based on the specific application itself. Essential for applying security services. Okay, let's discuss why App ID is essential for applying security services. Think of security services as the extra layers of protection on your firewall. These are things like threat prevention. This is like a security guard checking for known viruses, malware, or attack patterns hidden in the traffic. URL filtering. This is like having a list of bad websites and blocking people from visiting them. WildFire. This service analyzes unknown files or traffic patterns to see if they are malicious. Now, imagine trying to apply these security services without knowing the application. If you only see traffic on port 80, how do you know if you should check it extra carefully for malware? Is it normal web browsing, or is it a risky application trying to download something bad? App ID solves this. Because App ID accurately identifies the application, like knowing it's web browsing, online banking, or file transfer, you can tell the security services exactly what to inspect and how. For example, you can create a policy that says, for all web browsing traffic, apply threat prevention and URL filtering. For traffic identified as online banking, apply stricter threat prevention checks. If a file is downloaded within the Dropbox application, send it to WildFire for analysis. Without App ID identifying the application, you would have to apply these checks based on less specific information, like just the port, which would be less accurate and potentially miss threats or cause unnecessary inspections. By knowing the application, you can apply the right security service to the right traffic stream, making your security both stronger and more efficient. It ensures these powerful security tools are aimed precisely where they are needed, at the application level. Ensures consistent application-based security across Strata, NGFW, and SASE, Prisma Access, Cloud NGFW, deployments. Okay, let's explain. Ensures consistent application-based security across Strata, NGFW, and SASE, Prisma Access, Cloud NGFW, deployments. Imagine you have your main office network protected by a traditional Palo Alto Networks firewall. That's part of the Strata platform. NGFW stands for Next Generation Firewall. Now, also imagine you have employees working from home, connecting through a cloud-based security service, or you have applications hosted in the cloud protected by a cloud firewall. These are part of the SASE platform, like Prisma Access or Cloud NGFW. The challenge is often making sure everyone gets the same level of security, no matter where they are connecting from or where the applications are. This is where App ID is really important. Because App ID identifies applications using the same methods, signatures, decryption, etc., whether it's running on the firewall in your office, Strata, or in the cloud security service, SASE, the identity of the application is always the same. So, if you create a security rule that says, block the BitTorrent application, that rule looks and works exactly the same way on your office firewall and on the cloud security service protecting your remote users. You don't have to create different rules based on ports or IP addresses for different locations or deployment types. This means you get consistent security. The same application control and the same application-based security services, like malware inspection, are applied everywhere. This makes managing your security much simpler and ensures that users and data are protected consistently, whether they are inside the office, working remotely, or accessing cloud resources. Foundation for Advanced Threat Prevention. Okay, let's talk about why App ID is the foundation for advanced threat prevention. Think of it as the necessary first step to catch sophisticated attacks. Today, many threats don't just come in simple, obvious ways. Malware or attackers often try to hide inside traffic from legitimate applications. For example, malicious code might be sent within a file downloaded via Dropbox, or a command to a compromised computer might be sent disguised as normal web browsing traffic, command and control. If your security device only looks at the port or basic protocol, it might see port 80, looks like web traffic, and let it pass without checking deeply. But because App ID identifies the traffic as, say, Dropbox, or web browsing, and even the specific activity like file download, the firewall knows exactly what kind of traffic stream it is. Knowing the specific application stream allows the firewall to perform deep inspection within that application's data. This is where it can find the advanced threats, looking for known malware signatures inside a downloaded file within an application like Dropbox. Detecting exploits, attacks trying to take advantage of software weaknesses, hidden within the data flow of a specific application protocol. Identifying command and control, C2, communication, where attackers control compromised machines, which often uses legitimate application protocols, like HTTP or DNS, to blend in. Also, because so much traffic is encrypted, like secure websites using HTTPS, App ID often works alongside SSL, TLS decryption. The firewall needs to decrypt the traffic first to see the application data and then identify the application using App ID. Then, once the application is known and the data is visible, the threat prevention services can inspect within that clear application stream. In short, App ID's ability to identify the application stream is critical. It tells the security engine where to look for threats, allowing it to inspect the actual data within applications, rather than just looking at the outside of the network packets. This is fundamental to catching threats that are trying to hide. Enables inspection within application streams for known and unknown threats, malware, exploits, command and control. Okay, let's explain how Palo Alto Networks products can inspect inside application traffic to find bad things like malware or attacks. Imagine network traffic as a stream of water. Traditionally, security might just check the source and destination of the water, like which pipe it came from and where it's going. But what if something dangerous is inside the water itself? Because App ID identifies the specific application, it's like knowing that this particular stream of water is carrying, say, a file download from a specific website, or it's a chat conversation, or it's video data. Knowing exactly what the application is allows the security engine to look within that specific stream of data. It can open up the packets and inspect the actual content that the application is sending or receiving. This deep inspection lets the firewall find serious threats that are trying to hide. Malware. This is like finding poison hidden in a bottle of water that looks normal on the outside. The firewall can scan files being downloaded within applications like email, web browsing, or file sharing for viruses or other harmful code. Exploits. These are attacks that try to take advantage of bugs or weaknesses in software. Attackers often try to send special data within normal application traffic that can trigger these weaknesses. By inspecting the application stream, the firewall can spot these malicious data patterns. Command and control, C2. This is how attackers secretly control computers they've already infected. They often make the infected computer communicate with the attacker using seemingly normal applications like web browsing or DNS, but the actual messages are secret commands. Inspecting the application stream helps identify these hidden, malicious communications. So, identifying the application stream using App ID is crucial because it directs the security engine to look in the right place, inside the application traffic, to find these known and unknown threats that are trying to bypass basic security checks. Facilitates SSL, TLS decryption to inspect encrypted application traffic. Okay, let's talk about something very important for security today. Encrypted traffic, like when you see HTTPS in your web browser's address bar. Think of encrypted traffic like a sealed envelope or a locked box. It's great for privacy because only the sender and receiver can understand what's inside. But for a security device trying to protect your network, this is a problem. If the traffic is encrypted, the firewall can't see the actual data payload, it just sees scrambled information. The point facilitates SSL, TLS decryption to inspect encrypted application traffic, means that Palo Alto Networks firewalls often must decrypt this encrypted traffic to do their job properly. SSL, TLS is the technology that creates this encryption. Here's why App ID and other security features need this. 1. App ID needs to see the data. Sometimes, App ID needs to look inside the data stream to identify the application accurately, especially if it's using a common port like 443 for HTTPS. If the traffic is encrypted, App ID might only be able to make a general guess or identify it simply as SSL. 2. Threats hide in encrypted traffic. Bad things like malware or commands from attackers often travel inside encrypted connections, hoping security devices can't see them. 3. Inspection needs clear data. For the advanced threat prevention features, like finding malware or exploits, to work, they need to inspect the actual, unencrypted data within the application stream. So, Palo Alto Networks devices can perform SSL, TLS decryption. This is like temporarily opening the locked box. Once the traffic is decrypted, App ID can confirm the exact application, and then the security engine can inspect the now visible data within that application stream for threats. After inspection, the firewall typically re-encrypts the traffic before sending it on its way. Essentially, decryption is a necessary step that facilitates, makes possible, the effective use of App ID and subsequent inspection of encrypted application traffic, which is a huge part of the Internet today. Without it, a large amount of traffic would be a blind spot for security. Critical for identifying malicious activity hidden within legitimate applications. Okay, let's explain why being able to see inside legitimate applications to find hidden bad things is critical. Imagine attackers are trying to sneak something dangerous onto your network, like a virus or a way to take control of a computer. They know that basic security might block traffic that looks obviously bad or uses unusual ports. So, instead, they try to hide their malicious activity inside traffic that looks normal and comes from applications people use every day, applications that you have to allow for your business to work. These are the legitimate applications. Examples of malicious activity hidden in legitimate applications. Someone sending a virus file through a company's approved file sharing application like Dropbox or SharePoint. The traffic looks like normal file sharing. A computer infected with malware secretly getting instructions from an attacker using traffic that looks like standard web browsing, HTTPS, or even DNS lookups. This is command and control. An attacker trying to steal data by sending it out of the network disguised as regular application traffic. If your security only knows it's Dropbox traffic or web browsing traffic, based on the port, it might just say, "Okay, Dropbox is allowed," and let the hidden virus file pass through. This is why App ID, by identifying the specific application stream and allowing deep inspection within it, is critical. It's like knowing that while this is a delivery truck, the legitimate application, you need to open the back of the truck and check the package inside, the application data stream, to see if it's carrying something dangerous, malware, exploits, C2. Because Palo Alto Networks devices can see and inspect within the identified application stream, they can find these malicious items that are blended in with legitimate activity. They can spot the virus signature in the file, the exploit pattern in the data flow, or the command signals hidden in the web traffic, even though the application itself, Dropbox, web browsing, is legitimate. Without this ability to look deeply inside the application streams, a huge amount of dangerous activity would simply be missed because it's camouflaged within normal network traffic. That's why it's absolutely critical for modern security.